Okay, class, so today what we're going to do is we're going to analyze phase diagrams, and we're also going to learn about specific heat and how we're going to calculate heat, the amount of heat that's given off or absorbed during a chemical reaction. So the first thing that you need to know is this question: how are pressure and temperature related in terms of what phase a substance is, whether something is a liquid, a solid, or a gas? Like, how does temperature and pressure determine whether something would be a solid, liquid, or gas? So, according to the next slide, it says the state of matter, so whether something is a gas, a liquid, or a solid, depends on one of two things, or even both: temperature and pressure. Most people think, oh, temperature determines whether something is a solid or a liquid or gas, but pressure actually makes a huge difference too. Now, this is what we call a phase diagram, and you have to know the different components of this. So, right here on this phase diagram, um, obviously, when the temperature, so we look here, this is the temperature. When the temperature is really low, so you move to the left of this graph, when the temperature is really low, you're going to have a solid. Then as you increase the temperature past this line right here, it's going to be a liquid. So this solid to liquid is called melting, also known as fusion. And then as you increase the temperature here, the liquid starts turning into a gas once it reaches this region here. Okay, so the critical point here is the highest is the temperature and the pressure of which the gas and liquid states become identical. So here we both have a liquid and a gas. So at this point is where you cannot know the difference between a liquid and a gas. They say it is said that they coexist. The triple point is similar to the critical point, except it takes the solid phase into consideration. So at this point, if we have a temperature here at this temperature and a pressure here below 1 atmosphere, then um, we say that the phase is all three. You cannot distinguish between a solid, a liquid, and a gas. All three phases exist at the same time. Again, here the critical point is like the triple point, but it's only taking the liquid and the gas into consideration. So here is where the liquid and gas phase coexist. So if we analyze this really closely, if you follow where I'm pointing at, something at this pressure above 1 atmosphere, 1 atmosphere is the pressure at which gravity is the pressure, the normal pressure that is exerted on you when you're outside. So, for example, the pressure in the classroom is 1 atmosphere. The pressure while you're outside is 1 atmosphere. So, normal pressure would be 1 atmosphere. Atmosphere is the unit for pressure. So, if you go here, solid, liquid, temperature at a steady pressure. But if you lower the pressure to minimum, here is a solid, but as you increase the temperature, it goes straight into a gas. So, for example, dry ice, there's so little pressure inside of it that the dry ice is going to skip the liquid phase. Dry ice does not turn into a liquid, it goes straight into the gas phase. And that's because the pressure is very low. So, by pressure, I mean the particles are not moving very much, and they're all very compressed. And because of that, you're skipping the liquid phase. So just know down here, because there's a low pressure, you may be able to skip the liquid phase. But as you increase the pressure and then you increase the temperature, you're going to go from one state to another and then from one state to another. And just know the difference between the critical point and the triple point. So again, you have to know these terms. When you go from the gas phase to a liquid phase, that's called condensation. When you go from a liquid into a liquid into a solid, that is called freezing. when you go from a gas to a solid, that is called deposition. Make sure you know those three definitions. I'm pretty sure you guys know what freezing means. Freezing means you're making something into a solid. Condensation, you think of rain, you're turning a cloud, a ball of gas, into liquid, which is rain, condensation. And this one, deposition, is probably one that you did not learn in middle school. That's when you go from a gas straight into a solid. Um, and the other three are melting. So solid to a liquid is melting, also known as fusion. So don't forget, melting and fusion are the same thing. Then vaporization, liquid to a gas, and sublimation is, think of dry ice. Sublimation, dry ice. Sublimation is when you go from a solid into a gas. Okay, for example, air fresheners. They're solid, but then that smell is kind of like a gas. Okay, so the smell, goes straight into the immediate environment, which is a gas, because it becomes part of the air. So it's a gas. And again, you should know these two terms. The triple point is where all is the temperature and pressure at which all three phases coexist, and the critical point is the pressure and temperature at which only the gas and the liquid coexist. And here's another slide that shows what we just went over. Kind of just summarizes everything together. So at 1 atmosphere, you have a solid here, you have a liquid, and then you have a gas. If the temperature is very low and the pressure is very low, you could skip the liquid phase, so the solid will go straight into a gas, and that is called um, deposition and sublimation. So don't forget about those two terms. Sublimation means going from the solid to gas. So sublimation, think of dry ice, and deposition is just the opposite of that. Those are the two words that you probably should study tonight. And from there, just know that the melting point is the temperature at which something starts to boil. For example, at 1 atmosphere, what is the melting point? Tm stands for melting point, the temperature where something starts to melt. That would be 0. Excuse me. Okay. So at pressure at 1 atmosphere, the melting temperature would be about 0 degrees. Okay. And the boiling point of this substance would be 100 degrees. And obviously, this is water we're analyzing, because water tends to freeze at 0 degrees Celsius or start to melt at 0 degrees after you increase the temperature above 0. And water starts to boil at 100 degrees Celsius. So I'm pretty sure this is water. So here's an example of a question I asked on a quiz last year. You have a solid at a pressure of 30 atmospheres and a temperature of negative 15 degrees Celsius. If you decrease the pressure, okay, so you're decreasing the pressure at a constant temperature, what phases will the substance undergo? So we are going to go to you have a solid. So first of all, solids are all the way on the left side where it's region C at 30 atmospheres, which is right here, and negative 15, which is right here. So right here is my solid, but then it says if you decrease the pressure, so we're going to move down at constant temperature. So the temperature is not going to change. It's going to remain negative 15. What would happen if you decrease the pressure? What phases will it undergo? And if I go down, I notice that, I'm skipping the liquid phase. And if we look back, skipping the liquid phase means sublimation. So it's going from a solid straight into a liquid, and that's called sublimation. So if I ask on a test what process is this undergoing, you're going to say sublimation. If I say, oh, you're increasing the temperature from, I don't know, you're increasing the pressure. Let's say I say, okay, you have a pressure of 30 and the temperature is 50. So it's in the liquid phase. What would happen if you decrease the pressure? Then you'd say it's going from a liquid into a gas, and that is vaporization. So you have to know how to use your graphs. You have to know um, how to use basically just how to use a graph and what represents a solid, what represents a liquid, and this would represent a gas. The phase diagrams change depending on the substance. So obviously, this would not be water. This would be a very different substance. Most likely a substance that rarely is in the liquid phase. This is a substance that is very much in the solid and the gas phase. So it might be a gas, so something like gasoline or ethanol or propanol, something like that. Here's another example. Atmospheric pressure on Mount Everest is 0.29. What is the boiling point? So, um, so the boiling point is right here, and at 0.29 atmospheres, which would be zero point 0.5 would be here, 0.29 would be here. So the boiling point would probably be somewhere around here. So if you go down, it'll tell you the temperature. Um, Atmosphere pressure is 0.29. What is the boiling point of water in Mount Everest? It would most likely be around here. So maybe 40 degrees Celsius. That would be the the boiling point at Mount Everest. So if you go all the way up there, it's gonna be easier for you to boil water. Um, let's skip this. Let's skip this. Calorimetry. We're referring to calories. Calories refers to energy. So how much energy are you storing or using up? The more calories you consume, the more energy that is stored in the form of potential energy. And you guys know that if you eat a lot of fatty foods, it gets stored in your body in the form of fat, which is also an example of potential energy, which is stored energy. The first thing you need to know is what is specific heat. Specific heat is the amount of energy needed to raise the temperature. For example, you put a piece of metal outside of the, let's say, parking lot at ESAP, it's gonna easily heat up. But if you put like a I don't know, like a styrofoam cup with water outside of ESAT, it's not gonna warm up very quickly. And that's because water has a high specific heat. It requires a lot of energy to actually raise the temperature. So anything that has a high specific heat, it will require a lot of energy in order for you to raise the temperature. But if the specific heat is low, it's going to heat up very quickly. So that's where the definition comes from. Specific heat is defined by C. It is the energy needed to raise the temperature. So the specific heat is high. It's going to take forever for the temperature to go up. So here are examples. Metals obviously have very, very low specific heat, meaning that they're going to heat up very quickly. But things like water, for example, they have a higher specific heat, so it's going to require a lot of energy to actually increase its temperature. Here is an example of the formula that you're going to use for a specific heat. Calorimetry is the study of heat, and heat is defined by Q. Q represents the heat. M represents the mass of the object. C is the specific heat. That number is big if it requires a lot of energy to increase its temperature. If not, it's going to be low. And delta T is the temperature change. What is the temperature change? Temperature change is the final temperature minus the initial temperature. And the temperature could be in Celsius or it could be in Kelvin. Kelvin is a unit of temperature, in case you didn't know. And here is an example of a math problem where you're going to be using um, math, and I want you to go to part 2 of the podcast in order to know how to do these calculations. So if I give you M, C, and delta T, what's going to be the heat? If I give you the heat, the mass, and the temperature change, what is C? Or if I give you Q, M, C, and the final temperature, how would you find the initial temperature? So Go ahead and go to podcast number 2. It's also on that same website, on on my website, on that same slide. Just go to the second link.